Okay, hello. I'm going to go over exercise 5.3 for signal conversion. Okay, so we've just been given a DAC and some things there, and all it's asking us to do is calculate suitable resistive sizes. So we know the resolution straight away, half a volt, says it there, half a volt resolution, and we know logic 1 is 12 volts. So remember, gain is V out over V in also equals RF over R1. So V out over V in. V out is 0.5. Okay, strictly speaking, there's a minus sign there. We can stick that there if you want. Over V in, which was 12 volts, isn't it? Where's my old calc? 0.5 divided by 12. Excuse, 0. Oh, sorry. Yeah, we could do that, press equals. I'm not going to do it. I do apologise. Remember what we say. If that equals RF over R1, then quite simply make RF 5K. Yeah, what I've done is I've times the RF by 10, and then we'll make that 120 because we've times that by 10 as well. Do apologise. So what we want to do is asking us to actually physically write the values in. Yeah, okay. So A is R1. So A is 5. Sorry, R1 is 120K. R2 would be 60K, R3 would be 30K, and obviously R4, which is the feedback resistor, just check in. Yep, R4 is a feedback resistor, which we worked out to be 5K. So I do apologize, you don't need your calculator for that. You'd literally just do the same ratio, V out over V in, and times it by 10 if needed, or double it, or do something like that, just to keep it the same ratio. Okay. Next one. We're just basically going to climb the thing, aren't we? So what was the output voltage? It's oh gosh, it's half a volt resolution, isn't it? So it's going to be quite difficult to get all of those down, but we'll try. So half a volt resolution, and we're going down, aren't we? Because let me just double check. Yeah, we're going down because it's inverting. Okay, try and do this a bit neater than mine. So there's 1 volt. Let me just dot across here. If that was 1 volt, that would be half a volt. That'll be 1.5 volts. Can you see how difficult it is? Because I'm not. That'll be 2 volts. Quite difficult to do. So it's going to be nothing. Half a volt resolution. Down. The number 2 would be 1 volt. 3 would be 1.5 volts. 4 would be 2 volts, etc., etc., etc. Okay, so quite difficult to kind of do that on there, but that would be that would be what it would look like. So just take your time with that. But it's quarter of a volt resolution. Sorry, half a volt resolution, as you can see from there. Okay. Next one. Okay, this time I've just been asked to design one. So what is it? A 3-bit DAG. What I would always do, I always like to draw the thing first. So let's just draw one because I think it in my head it's a bit easier. So let's just draw it first. So number of bits 3. So it's a 3-bit DAC. A, B, C. Feel free to pause me to have a read of this, by the way, guys. You don't just have to watch the video. You can pause it and have a little read, then play a game. Okay, so that's your circuit. It tells us that the output voltage range is from 0 to 14. If it's a 3-bit, I know I've got 7 steps. I know that my resolution would equal, obviously, 14 divided 7, 2 volts. So that's my resolution. That's the smallest voltage step. Okay. A logic 1 is 10 volts and a logic 0 is 0 volts. So if I put 10 volts into that bit, I should get 2 volts. Okay, you are right. It should be negative at that bit. So we do that in a different color. Go for a blue. I'll go for a brown. So 10 volts there, volts there, minus 2 volts there. Okay. So basically gain is V out over V in, gain is V out over V in, as we know. It's got therefore minus 2 over 10. It's going to be a fifth 0. Fifth 0 point minus 0.2, okay, or a fifth. So if you've been given these values, two 222k resistors, one 20k resistor, one 4k resistors, and we need to work out the other resistors. Because it's been given those ones, that tells me straight away we need to flip. We need another op amp to flip it back up. So I'm going to get that out of the way and just do that now. So they're the 220k resistors sorted. So they're the 2Ks, 220Ks. There they sorted. And then notice if the gain is a fifth, then obviously look at those numbers. They've actually given you the feedback resistor and that resistor there because it's a fifth. Okay, they've given you that. I don't think that I'd ever see a question where they wouldn't give you the least significant bit resistor. I think that would be too hard to work out. So I think they'll always give you the least significant bit. And then how would you work out those? We don't need to work them out, just write them on. Okay, you know how to do all of this. It's just practice, isn't it? So maybe you want to go back to the previous one, the 5.2 one again, try that, and then come back to this one and try it again. I think that's it for that one. Okay, so just using gain is V out over V in, gain is minus RF over R1. I know I sound like a broken record, but it's all the same stuff, isn't it? And obviously a bit of ratios going in there. Okay, thank you very much. Oh, stop that.